All right, how about this rectangular picture right here? Well, that's a nice rectangular picture. Let's see if we can draw a picture of it. Sorry about the pun. But this one says that the length of the rectangular picture is 4 times as long as the width. Okay, so again, I know that my length is the same as taking 4 and multiplying it by the width. The width, of course, is just the width. The other thing I know is that the area of a rectangle is just the same as taking the length and then multiplying it by the width. Okay, so looking at this picture right here, of course, we have width and we have length, but if I kept it this way, it doesn't really help me. I want to show that the length is 4 times as long as the width. Okay, so over here, the length, just like we've shown in the equation there on the left, I'm going to replace it, instead of showing it as L for length, I'm going to show that it's the same as taking 4 of the widths and multiplying it 4 times the width. Okay. So in my formula for area, right, it says over here, there the picture is 100 square inches, so that's a 100 equals the length. But now my length, I know, is 4 times the width, and then that still is multiplied by the original width. Okay. Now to simplify this, I now have 100 equals, I got 4 times W, right? All that together is still multiplication, but it's 4 times W to the power of 2. And you'll see why that's important here, because I'm going to solve this like I would one of those other equations. And so I'm going to get rid of that 100. I'm going to make it a 0, right? So I'm going to make it 0 equals 4W. I'm going to drop that 4W squared. And you see I subtracted 100 on the left, so I must subtract it on the right as well. So I got 4W squared minus 100. Well, why is that important? It's because 4 and 100 are perfect squares right there. So what I'm trying to do here is I see that I have a difference of squares. So I'm expecting an addition and subtraction binomials on this. Of course, it still equals 0, right? So what is it that's being squared? Well, from the 4W, that'd be the same as taking 2W and squaring it. So I know that's my first value is a 2W in both binomials. And then 100 is the same as taking 10 and squaring it. So it'd be 2W plus 10 and then also 2W minus 10. These two binomials are being multiplied together. But again, that still equals 0, right? So I got to take the 2W minus 10. Perhaps this is more work than you'd want to ever show, but I'm going to show it. So 2 times the width plus 10. If I were to solve this one, because remember, if I could just make that equal to 0, then that would make the full equation true, right? So I'm going to take that, I'm going to subtract 10 from both sides. Drop my 2W, we zeroed out the 10s. 2W equals negative 10, and then divide both sides by 2 to make the width. It could be negative 5, right? Now, I said that out loud on purpose so that you could understand how that's going to work. Whether you did or not, we now have a second binomial that we should check. So that was saying that if 2W minus 10, if we could get that binomial to equal 0, then it would still make the equation true, right? So we take that, and we're going to solve this one as well by adding 10 to both sides. Drop the 2W, the negative 10 zeroes out, and that now equals 10. And the last thing we got to do there is divide both sides by 2. Okay, so the width, it could be negative 5, or it could be a positive 5 inches. So I'm purposely labeling these just so you can see exactly what's happening. We can't have a measurement that is a negative length right there, or width in this case. So that one can't be the case. It did want the width and the length though, right? So right there, it's okay, I do have my width. But here's what I notice is that the length is 4 times the width. So I'm going to take my length and I'm going to make 4 and multiply it by the width, which is 5. Okay, which should make the length 20 inches. Okay, now if I've done this correct, then I found my length and my width. Does this work though? Well, 20 inches is 4 times 5, so that takes care of the first condition. The second condition says that the area should be, of the picture, it's rectangular, should be 100 square inches. So 20 times 5 is 100, and then it checks off both conditions, the only two conditions that it gave me in this problem. If I didn't get 100, or if I didn't get that the length was 4 times the width, then I'd have to go back and redo some things. But this one checks off, and now we know we've even labeled them, right? So we're in good shape right here. This problem's good.